Hey guys, Stat 1800. I'm putting this video up at home today, and I know you don't care where I'm putting up the video, but I kind of prefer this to my office. But anyway, if the UPS guy or comes, I'll have to take care of that. Guys, purpose of this video is kind of twofold. First thing I want to do is I want to get into my stat lab, my math lab, and work 4 types of problems. Just to give you an indication of some things, in the class syllabus, I told you that the requirements for this class are to watch videos, and I know there's been a lot of videos this week. The number of minutes hasn't been that much, but I'm sure you're just sick of listening to me. Just go ahead and cut to the chase here. But if you look back at the requirements of the class, it's to watch the videos. So instead of coming to class, you have the option of watching these videos on your own time and submitting the assignments. Guys, it's so easy to get into a habit of just doing the assignments and not watching the videos. And guys, it's going to catch up with you if you do that, because your exams, which most of your grade depends on, will be kind of a mix of the problems that I do from the videos along with the problems that are in the my math lab assignments. So anyway, that said, please watch the videos. I'll try to compress them and cut down the number of minutes as much as possible, but sometimes I'll ramble on like I'm doing right now, and they'll be longer. All right, guys, one thing before we get into the My Stat Lab demo problems. What kind of a parting word about boxplots. Boxplots pretty much do 2 things for us. They represent outliers. Well, I don't guess they represent outliers, but the graph of a box plot will display the outliers. And they also give us a graphical representation of the 5-number summary. Now, I think it's important to point out to you that, again, as we should know by now, that for some reason I have a hard time writing and talking, which usually isn't a problem for me. But anyway, the 5-number summary consists of the low number, Q1, Q3, the median, and the high number. So if we would have something like this, let's say the 5-number was, the low number was 5, Q1 was 25, the median was 32, Q3 was 50, and the high was 100. I see so many times that people will take this 5-number summary and do a box plot, and they'll do it like this. All right, what's wrong with that? Looks like it kind of represents these numbers, right? I've got those numbers right here. Guys, the problem with this is it doesn't give you the opportunity to create a box plot that gives you the variation between these 25%, including identifying outliers and displaying outliers and displaying the 5-number summary. The main purpose of a box plot is to give you a visual, give you a graphical representation of the variation within these 25% segments. Because guys, what we do to create a 5-number summary is we take the low data, arrange it all the way up to the highest piece of data, and we come in and make cuts. We make a cut in the center, make a cut there, and a cut there. So what we do is we make 3 cuts for our quartiles. Along with the low and the high, we have a 5-number summary. The purpose of a box plot is to look at the variation between here and here, here and here, here and here, and here and here. So guys, what you should do here when representing drawing a box plot by hand, and we won't do that much anyway, is set up your axis according to the small number and the high number. So I would probably come in here at 0 and go 0 to 100 by tens. Then I would come in and make these marks. So I'd make a mark at 5. I'd make a mark at 25. I'd make a mark at 32. I'd make a mark at 50. And I would make a mark at 100. Then I would draw the verticals and the horizontals, giving me an indication of the spread between the endpoints of the first 25%, the second 25%, the third 25%, and the final 25%. So guys, keep in mind that 25% of your data falls between this value and this value. And you can see right here from Q1 to the median that there's not as much spread in that 25% of the data as there is in the upper 25%. So we have a lot more variation in the upper 25% than we do in the second 25%. So guys, I hope that helps. It's an important point for discussing box plots. Okay, and you know, I didn't have any outliers here, so no outliers are represented. But all right, guys, let's get out of here and let's get into my math lab. Now, I'm posting this video in August of 2017, but I intend to use this video for future classes. So, you know, these dates over here may not apply to you. They're going to apply to this class because this is the class I'm putting up the video, but I'm going to use it in future classes. So if these dates don't coincide, don't sweat it. But regardless, when you're taking the class, there's going to be a homework assignment. Again, it's a demo, not for credit assignment, but it's just to learn, for me to work problems and show you some features on my stat lab and teach some statistical concepts in this assignment. So, gang, I'm going to click it. I'm going to go to question 1. There's only 4 questions. I've let each one be 1 point, again, because you don't get a grade on it. This is for your learning. All right, so question number 1 says the accompanying table contains the average room price paid by various nationalities while traveling abroad away from their home country in a certain year. Complete parts A through C. So compute the first quartile, the third quartile, and the IQR. Well, our data is right here. And, you know, I can go through here and put these in order by hand and calculate all this stuff by hand, but I don't want to do that. I want to let StatCrunch do that. So I'm going to open up in StatCrunch. And I am going to go Stat, Summary Stats, Columns, choose the variable, and then I'm going to go through and I'm going to choose the things that I need. Well, I needed Q1, I needed Q3, and I needed the IQR. So I see that, and guys, I've got my sheet of paper over here that I use to tell you about the, to point out some things about the box plot. So I'm just going to write those things down before I go over. So 150.5 is Q1, 173 is Q3, and then 22.5 Q3 minus Q1 is the IQR. So close this down. So it says to do not round, type integers or decimals. All right, that's cool. So 150.5, Q3 was 173, and the IQR was 22.5. All right, so check answer. It's going to be right. Cool. Now, list the 5-number summary. Well, all I need is the low and the high added to this. So if I go back to this and get the low and the high, I can actually go through and see that the what the low is 144 and the high appears to be 178. So I can just add that to my previous. So 144, I think I said 178, I forgot. Yeah, 178, and then 150.5, 173. And 20. No. Guys, I messed up here. I need to get the median. So the median is 165.5. And 173. I think I got that right. Let's check it. One thing about it, if you didn't, it'll certainly let you know. Construct a box plot and describe its shape. Now guys, notice that the box plot goes from 130 to 190. All right, so I want to do a box plot. Let's get rid of this. All right. Okay, fences to identify outliers. So we always want to do that. We don't want to group. Well, I thought there was a way that you could set. Well, anyway, we should be able to get this. I'll tell you what. Let me do a horizontal. Okay, horizontal lines, vertical lines. Guys, I thought there was a way that we could do horizontal, draw boxes horizontal. There we go, and use fences to identify outliers. All right, cool. So you know, we just need to take a look at our 5-number summary and make sure that it matches up. So I don't know about you, but I can't really see that one. So does this look like that? So what I see here is I see the two outer fences here. I see those about the same, but I see that second 25% is having more variation. So when I look down through here, the characteristic, or the box plot I see with that characteristic, is clearly B. So that's the one I'm pretty sure it is. Now the data are roughly symmetric because the left tail is roughly the same as the right tail. Now it's catching me on a technicality there, because when somebody says roughly to me, that is roughly the same as that, but it's it's the reason you get multiple opportunities, right? And also the reason this will not be a test question when your grade's really at stake and you don't have multiple opportunities. So the left tail is actually a little bit more, so its interpretation of roughly the same is not the same as mine. So so we would say that it is left skewed because the left tail is longer than the other. All right, I don't really like that because I don't, but it is what it is. All right, the data yields for 1-year CDs, 5-year CDs for 13 banks, complete part A and A through C. So compute the first quartile, third quartile, and IQR for CD. So guys, first thing I want to do is I want to import this into StatCrunch. And again, what do I want here? I want Q3, the IQR, and so it's for 1-year CD. All right. I guess what I'm going to do is I'm going to predict what I think they're going to want. So I'm going to go ahead and add both variables, because I'm just assuming that ultimately I'm going to want to need that. And I'm also going to assume that I'm going to need the median, Q1, Q3, and the IQR. So I'm just going to go ahead and get it all. All right, guys, so I have everything now. So it wanted Q1 and Q3, so that would be 2.87 and 4.06. Then it wanted the IQR, so the IQR is 1.19. Now, what is the IQR? The IQR is actually the range of the middle 50% of our measurements. So now I want the IQR for, or Q1, Q3 and IQR, so I have that. 3.62 and 4.27. And people told you statistics would be hard. No way. Well, it does kind of get harder later. 0.65. Guys, I think you can go 0.65 or just 65, I'm pretty sure. So, all right, guys. The inner quartile. Okay, list the 5-number summary for the yields of the 1 year and the 5 year. All right, so I actually should have. Well, I guess I can eyeball this. So it looks like the lowest is 2.47. All right, you know what? I don't want to do it this way. I want to do the low and the high as well. So I'm going to go back through, because what will happen is you'll get into your homework assignment and you'll have like 85 numbers and you can't eyeball it, and you'll be like, well, Darbo didn't tell me how to do that. So I'm going to go ahead and do things the proper way. So guys, what I would want to do is I'd want to come in and get the median. I'd want the min. I'd want the max. I'd want Q1, Q3, and I'd want the IQR. Okay? All right. So I need to add 2.47 and 4.82. I did say 8.42, right? 4.82. All right, and I can get the information up here. So it looks like 2.87, and it looks like the Q3 was 4.06, and it looks like the median is 2.96. All right, hopefully no typos. Same thing, let's do the low and the high. The low is 3.47 and 4.94. So 3.47 and 4.94. I can get Q1 from above, 3.62. And I can get Q3, 4.27. And the median I just found, so the median is 3.79. All right, guys, easy stuff. All right, construct a box plot and classify the shape. Okay, so a 1-year CD. We want to do a box plot. And guys, I'm going to assume I'm going to want a box plot for both of them, so I'm just going to go ahead and do it. It's on the same axis, pretty close, and so yeah. So what kind of characteristic is going to distinguish? I can see that the right tail is longer, and when I look in the center of the box, the middle 50%, the IQR, the third 25% is bigger. More variation in the third 25%. So when I look down through here, and it only gives me 3 choices, it looks like to me that the one that matches up will be C. All right, does the shape of the box plot choose the box plot shows a right skewed distribution? Now this was pretty clear because you know, you've got the so much more spread in your right, well, your third 25% and your right tail. So feel much more confident with that. All right, which of the box plots is for the 5-year? What distinguishing characteristic do we have here? Well, again, there's a huge discrepancy in the variation from the second 25% and the third 25%. So that's what I'm looking for. This has that characteristic, but notice there's no variation in the bottom 25%, whereas there is in part B. So now this also shows a right skewed distribution because of reasons we've talked about before. And we go to the next question. All right, the following, so compute the mean, median, compute the range, variance, a coefficient. Okay, so I need the mean, median, and mode starting out. So, gang, I'm going to get rid of all this stuff. And I'm going to open this in StatCrunch. So I want the mean, median, and mode. Now guys, what we're doing here is we're finding the 3 measures of center. So I want the mean, the median, and the mode. So the mean is 6. The median is 5, and there's no mode. All right, so the mean is 6. Type is an integer or decimal rounded. Well, guys, did I get the wrong? The mean is 6. Well, this is fun. Type is an integer or decimal to 4 places as needed. So, is it getting me on a technicality here? All right, what's going on here? This is interesting. So I have the 5. Oh, I see what happened. It didn't include the 5. It named the variable as 5. So, guys, I need to come and put the 5 in there. And then just rename this as like, you know, data or something, whatever. So, wow, that was tricky. I don't like that at all. All right, whatever. If they want to be tricky, we'll figure them out. All right. So, 5.83. So it says to go to 4 places. So 5.8300. Huh. Oh, shoot. Well, no, I just got sloppy then. That was just sloppiness. All right, so I'm really disappointed with myself there. So guys, you would have the opportunity to go back and do this over, and that's what I would do because obviously I know what I'm doing. I got sloppy. All right, now we want the range, and I'm going to write this down so I know what to get when I get over there. Variance, the standard deviation, and the coefficient of variation. So I need 4 things from the status set. So let's do it. So I need the variance, the standard deviation, the range, and the coefficient of variation. All right, so the variance is 17.7667. Don't want to round wrong, right? The standard deviation is 4.2151. The coefficient of variation is 72.2580, and the range is 12. All right, so the range is 12. S squared is the variance, so it's 17.7667. Around to 3 places. Wow. All right. You know, I'm actually kind of glad this is happening. It's kind of embarrassing that I'm not paying more attention. Actually, my cat, well, actually not my cat, my daughter's cat is messing with me, so I'm kind of distracted. That's my story, and I'm sticking to it. 2, 1, 5. Is it 3 places? Yes. And the coefficient of variation to 3 places, so 72.258. Okay, guys, we're on to finding the z-scores, and I have to confess to you that I got distracted and ended the video, so I'm starting another video. I'm just going to kind of weld these, or weld them together. You have to weld metal, but or steel, but I'm going to weld together videos. Imagine that. So, guys, what I would do if I were going to calculate these z-scores is I would use the compute expression in my stat lab. So I would go to, I think it's under data, go to compute, I would go to expression, and for expression I would build. So what I know is to calculate the z-score, I need to, in the numerator, in parentheses, take the score minus the mean and then divide by the standard deviation. So I would go ahead and put this in parentheses, and I would take data minus, and I would come over here and find the mean. Double click it, and I want the mean of the data. And again, the reason I'm putting data here is because that's what I named the variable. All right, so I'm going to go divide it by, and then I'm going to go down and get the standard deviation. Double click it, take the standard deviation of the data. All right, I'm going to hit OK, and I'm going to go compute. Now, you'll see that I have my values. So the 5 was negative 1.98, which you can see I put there. So now I need to find the value for 1. So that would be negative 1.147. The 3 is negative 0.672. And what you just hope here you just hope that you didn't you don't make a typo. Well, guys, 5 has to be the same z-score as the other 5. That'd be kind of wacky if it wasn't. Eight is going to have a positive z-score because it's above the mean, so 0.514. And finally, 13 also has to have a positive z-score, 1.700. We like those. All right. Are there any outliers? Well, let's do. You know what? I take that back. Typically, on outliers, I'm kind of programmed to calculate, or I'm sorry, to create a box plot But this book actually wants you to use the rule, at least for now. If you have a z-score above 3 or below -3, then you have outliers. And since all of our z-scores are between -3 and +3, we do not have outliers. All right, guys, on to the final question. So 3 of 4 is complete. So let's go on to question number 4. Uh-oh, we've not, you sure we want to leave? No, I don't want to leave. I thought I was done. Oh, what is the shape of the data set? Well, the mean is bigger than the median. So that would mean we have a positively skewed, right skewed distribution. Okay, same kind of problem, really. I don't know why I included this. Really, just calculate the first and third quartile, the 5-number summary, construct a box plot. Guys, I'm going through this. If you don't want to watch it, I don't blame you. It's up to you. But I'm going to open it up and play the game. Make sure nothing wacky's going on with the variable, one of the measurements being the variable name. That was rather frustrating. So what do we need? We need Q1, Q3 in the IQR. So 495. Now this would be awful to throw in a sneaky quiz right now, wouldn't it? Since I just told you that you don't have to watch it, because I'm not going to do that to you. So I need the median and the small. So in addition, I need the median and I need the min and the max. So 7 and 316. So 3, 16, 7, 4, and 9. This is an easy problem. These are much easier when we don't have decimals. Which box plot? Let's do it. All right, the characteristic here, I see the second 25% has less variation than the third 25%. And of course, the right tail has much more variation than the left tail. So I need something like that, and it looks like to me B is the only possibility. Shape of the distribution, guys, this is I would say more than slightly right skewed. I would say definitely right skewed. All right, guys, that's it. Thanks for hanging around. Take care.